Hello, how are you? I'm fine. Today I'm going to show you how to analyze linear regression in R software, and which is very essential. And as all we know, R software is a free software, and it is very intelligent software that are mainly used by statisticians. So today we're going to learn about advanced linear regression, from the first initial step of how to conduct linear regression, what's linear regression, and from the preliminary session of checking each assumption one by one up to modeling, or up to modeling our data. Okay, so first we should have to know what is linear regression. Okay, so as all you know, linear regression is a regression model that uses straight line to describe the relationship between two variables. Okay, or in general case, let's say relation between a variable. Okay, so to apply linear regression, our dependent variable should be measured on continuous scale. Okay, and that plus the independent variable may be measured on either continuous or categorical or dichotomous variable. Okay, so first, in general in statistics, when you say linear regression, there's two types of linear regression. Okay, the first one is simple linear regression. As the name indicates, simple, it uses only one independent variable. Okay, bear in mind that in both of simple and multiple linear regression, we use only one dependent variable. Okay, so when we say multiple linear regression, we use greater than two independent variable. Okay, that's the main difference between them. Okay, so in today's example, we illustrate on, we analyze a data set which have two variables. The first one is income, and income is measured in a number, and happiness is another variable which is considered as independent variable in this example, and which is measured in scale of 1 up to 10, meaning that it is categorical variable. Okay, and totally our data is collected from 500 people, and we consider income as dependent variable, which is, so our income is ranged between 5,000 and 75,000. So we should have to make our variable standardized. Okay, so we divide all values by 10,000, so our variable may be what? Standardized, meaning that the period 20,000 may be now stated as what? $2. Okay, so as all you know, in mathematics, it's possible if you are going to standardize a variable by dividing with the same divider. Okay, with each when you divide all of observation by the same value, it is the same. Okay, so now we standardize our variable. Okay, that's the main issue. Then the next step is to analyze this advanced linear regression in R. The following package should be installed. Okay, if you didn't install the following package, you should have to install before going to analyze this example. Okay, and since I'm already installed this package, and and if you installed in another time, you should have to run the following code. Okay, if you already installed the above package, the next day you should run this one. Okay, to load the already installed package, and this also I'm done with this one also. Then our today's topic is focused mainly on advanced simple, simple linear regression. So both of our variable is most likely quantitative. Okay, quantitative. So the first step is uploading the data. Okay, you should have upload our data. So first, if you don't have a data, I put the data on the description, so you may download the data and upload to your R software. and then click on view to view the data, which is I'm already done with also. So the data is now look like this one. Okay, the first we made that we standardize our variable income. So now our variable income is standardized, and this one is the variable called happiness. So this is what our data look like. And the next step is, as all you know, before modeling the data using the statistical model, the first thing is running the descriptive statistics. Okay, so to get the descriptive statistics in one command, we say summary, and we write here the name of the data. Okay, then I run this one, run, then our result is displayed here. So as you considering, this summary command displayed 5 summary number. Okay, the first one is for each variable they produce minimum, first quartile, median, mean, third quartile, and the maximum for both of two variables. Let's consider this one. For the income, the minimum income is what? 1.5k. Okay, 1.5k. Okay, since our variable is standardized, bear in mind that. Okay, the first quartile is, or Q1 is what? 3.006. Median is 4.42. Mean is 4.46. Third quartile or 0.5 quartile is what? 5.57. And the maximum of the income is what? 7.4. And for happiness also, we have 5 number summary. Okay, here the first one minimum, then quartile 1, median, mean, third quartile, maximum. Okay, this is called the 5 number summary. Okay, so it's possible to interpret our mean. The first, on average, the income of the people is what? Around 4.4 let's say dollar, if it's measured in dollar. Okay, also and the happiness may also we interpret. Okay, as we know. That's all about. And the next step is, before going to analyze our data, we should have to check each and every one of simple linear regression assumption. Okay, as all you remember, the first assumption of linear regression is what? Linearity assumption. Okay, linearity assumption. This is very essential assumption of general linear regression. Okay, then this linearity assumption says that there should be linear relationship between independent and dependent variable. Okay, this must be. Okay, to stick with this linear regression, this assumption should be fulfilled. Okay, so to plot or to check for linearity assumption, we run the following code. Okay, plot, then we write the name of dependent variable. We consider this happiness as dependent, and which is affected by the income. Okay, the independent variable. Okay, so if you consider happiness as the outcome variable or dependent variable, we write the happiness in the first one. Okay, then tilde on the dependent variable. This one is dependent variable. Always we write the dependent variable first, then next independent variable, and we state the data name. Okay, data, which is equals to the name of our data. Okay, then we run this code. Then as you see, we got such like plot. Okay, and this plot is pretty good. Okay, right? And as all you know that this plot shows that as the income of the household or the people increase, the happiness score of them is also increasing. And this one shows that. And when we put the straight line on this, on the middle of this graph, it shows that there's a linear relationship, which means that the positive linear relationship between the income and the happiness. Okay, so the first assumption of linear regression is now fulfilled. Then the next step is checking the independency of observation. Okay, as all you know, the second assumption of linear regression is the independency assumption. Okay, So this assumption says that because we only have one independent variable and one dependent variable, we don't need to test the hidden relationship between among variables, okay? And most likely we check for independency assumption when we are running for multiple linear regression. Since in multiple linear regression we have greater than one independent variable, so we should have to check the relationship between independent variable, and bear in mind that the independency assumption in linear regression is talking about the relationship between independent variable, not dependent with independent variable, okay? That's the main issue, okay? So in the simple linear regression we don't need to have, or we don't need to check the independency assumption since we have only one independent variable, okay? That's the main point, okay? And the third assumption, as all you know, is what? The normality assumption. This one is pretty assumption, or most well-known assumption in statistics, so we should have to check for the normality assumption of what? Dependent variable. And then bear in mind that when you check for normality assumption, we only stick with what? Dependent variable. That's all about, okay? We don't consider for independent variable. So let's plot the histogram, okay? Plot the histogram of income data. That's the name of data, okay? That's the name of data. $sign, which command that from this set of data select happiness variable. That's the use of $sign, okay? Then we run this one, hist represent for histogram, okay? And as all you know that normality assumption is checked by what? Plotting the histogram, okay? This is cool histogram, okay? As all you see, this is which our data or our data of happiness is distributed both sides around the mean, which is in equal way, okay? This is called bell-shaped distribution. So if our data is distributed such like, which is below the mean and above the mean equally, then our normality assumption is what? Fulfilled. So in our case, the normality assumption is what? Fulfilled. So the next step is, as all you know, the fourth and the most prominent assumption of linear regression is what? Homozygosity, or in another name, homogeneity of variance, okay? Homozygosity or homogeneity of variance. And this assumption says that we can test this assumption later, okay? This assumption says that between the variable, the variance of each and every observation may be what? Homogeneous, okay? So this assumption may be what? Checked before modeling or fitting our data, okay? That's the main point, okay? Always in the first stage we check for the linearity, independency, and normality assumption, and homozygosity or homogeneity of variance is most of the time checked after fitting the linear model, okay? Now it's the time to perform or model our data, okay? Since the first assumption of the main assumption of linear regression is fulfilled, so now let's model our data. Now that you have determined your data meets the assumption, you can perform a linear regression analysis to evaluate the relationship between dependent variable and what? Independent variable. In our case, independent variables, we are going to consider the income as independent variable, and dependent variable is happiness, okay? So let's conduct the simple linear regression to see the relationship between the income and happiness, okay? Let's proceed. So to fit, we say income dot happiness LM, okay? And this here LM represent for what? Linear model, okay? Then our dependent variable is written happiness, tilde on independent variable income, and the data we set, and we write the name of data, okay? Then we run this one, okay? First. Then to see the result, we say what? Summary. The name here, this one, income happiness LM, we write here, and we run also this code to get the final result. Then our final result is look like this one, okay? This is so pretty cool, okay? Here in the first case we got the formula to analyze this model, and in the first column we got the residual, okay? So the residual is summarized in 5 number summary. The first one, the mean of the residual, and all you know, the residual is what? The difference between what? Observed and what? The difference between what? Observed and fitted, okay? That's the main point. So here, first quartile means that Q1, median, Q3, maximum, okay? This 2.3 represent that. In the residual, there is 2.3, okay? 2.3 represent for there is a difference between observed and fitted, okay? That is scored for 2.3. And this one is our model, okay? We need this one, this part. The intercept one is 0.2 is the beta naught. The income is 0.71, and both beta naught and beta 1 is significant. Now here we have standardized residual, multiple R square, adjusted R square. So let's interpret one by one. Let's interpret one by one. Okay. The next step is the finally reline our model diagnostic. Okay. The most important thing note is p-value. So our relationship between the dependent and dependent is what? Significant, which means that what? Since the beta 1 is what? Significant. So this will indicate that our model is what? Well fitted. Okay. እዚህ ጋር ብንመለከት this F statistics is stand for what? The overall significance of the model, okay? So if this value is significant, it says that what? Our model is what? Significant. Okay? That's the main issue, okay? The other part is let's interpret each coefficient one by one, okay? To interpret this one, first we look for beta naught, or most likely in linear regression we stick with beta 1. So let's interpret beta 1. The coefficient of beta 1, as all you see here, is 0.71. And how to interpret this one is the main issue, okay? So let's interpret from this one, okay? As all we know that there's a significant positive relation between income and happiness. Since the coefficient of beta 1 is what? 0.71, which is positive, it represents what? A positive relationship between income and happiness. If it is negative, there's negative relationship between what? Income and happiness. And this positive value of beta 1 represents that as the income increases, the happiness of the individual is what? Increase. Okay? So this represents that 0.73 increase in happiness for every unit in increase in what? Income. Okay? So here we say that if the income of 0.3 unit increase in happiness for every unit increase in what? Income. If the income of the individual is increased by $1, the happiness of that individual is increased by what? 0.713. That is the issue of how to interpret our coefficient, okay? And as I told you earlier, I said that we check homozygous assumption at the end, okay, after fitting our linear model. So it's the time to check this homozygous assumption, okay? So the point is how to check this homozygous assumption, okay? To check for this homozygous assumption, we should have to first set the following issue. Parameter m for row 2 by 2. It's setting what? We need space for that. Take the 2 by 2 graph, okay? And this plot is what? Used to check for what? And the plot say, plot, here we write what? The final model name. Here in the above, we use the income happiness LM to analyze what? Or to model our linear model. So we put here, okay? Plot, then this, and this command is used to what? Used to check for homogeneity assumption, okay? Assumption. And this command tell the R that we need 2 by 2 we need 2 by 2 graph in one plane, okay? And this says that what we need, that's 2 by 2 graph in one plane, and this we need 4 graph, okay? And let's run this command, okay? And now here our result is here. So in one plane we have what, 4 graph. That's all about, okay? Here the first part, 1 is what, tell our alpha what, in one plane we need what, 2 by 2 two row, 2 column graph, okay? That's the point. So the first residual versus fitted is used to check what, the homogeneity or heteroscedasticity assumption, okay? So above the mean and below the mean, and which line is drawn on horizontal line on 0, which is show what, our distribution or residual versus fitted one is what, distributed below and above the mean equally. So this represents what, there is homogeneity or equal variance between what, each residual, okay, versus the fitted one, okay? And this one also, standardized residual versus theoretical quantile, there is straight line which shows that the normality assumption is fulfilled, okay? As you see here, the normality assumption is, or the normality assumption is fulfilled, the homozygous assumption is fulfilled. Now it is possible to predict or use this model. It is right, all of the assumption of linear regression is fulfilled. Now it's the time to use this model, okay? Okay, based on the homozygous assumption, as all you see now, our model fulfill all the assumption, and now it's the time to use this model, okay? Then the next step is, as I said, let's visualize our data. Let's visualize by using ggplot2, okay? First, to visualize our linear regression, the first, let's say, income.graph, ggplot, and here we write what, the data set name, then s asterisk, which is we need on the x, on the horizontal axis we need income, and on y axis we need our dependent variable plus what, geom point, okay? Let's run this one. Sorry, let's run this one. Okay, here as you see, by using this command we got the following plot, okay? On y-axis we have our dependent variable, that's happiness. On x-axis we have our independent variable, that is income. And then, as all you see, as I said earlier, this one is more sophisticated graph, and which is drawn by ggplot2, which is more professional way. Then as here, as you see, as the income increase, the happiness of the individual is what, increase. And all you know that when you plot our graph using the ggplot, our graph is more sophisticated, more intelligent, more professional. That's why we need to plot our graph using the ggplot2. And let's proceed to the next. And now, if you want to add linear regression line to the following, to the previous graph, we add, or it's possible to add the following command, okay? As you said, first income graph, because then the next step is what, income graph plus this income graph stands for what, the previous one, okay? So now we are going to consider the previous graph plus what, another additional line that represent for linear regression plus what, geom smooth method, linear method, then column black. Then we run again it. Wait. Wow. Very cool, okay? It's so pretty. Now we have the line. So this line represents what? The linear model line, okay? And more gray one is stand for the confidence interval upward and the lower confidence interval. Okay, so this line stands for what? There is a linear relationship, perfectly linear relationship between what? Income and happiness. Okay, so another step is let's add the regression line on the graph. To add the regression line on the graph, we repeat the same procedure. Income graph plus stata regression line equation, label 3, label of y 7, and then this let's run the following command, and we got the following. Okay, so here in the upper corner we have the linear regression equation, and this 0.1 is stand for beta naught, and 0.71 stand for what? Beta 1, which is our model equation, our final linear regression model. Okay, and now let's ready our graph for publication. Let's assume that you are going to publish the article which is modeled by simple linear regression on one journal. Okay, so your graph should be look like more professional. Okay, to make that one, let's add another feature. Okay, we repeat the same procedure. Income graph plus team between plus late label. We gave the title reported happiness as a function of income, and we label also the income, which is measured from in 1000K, and the late label y, which is happiness score measured from 0 to 10. Okay, that's all. Now our graph is look more professional than ever. Okay, since here in happiness there is happiness score which is measured from 0 to 10, and in income also we have stated that which is income is standardized by $10,000. Okay, now we have more professional graph. That's all about I wanted to show you today, and I expect that you learn more from this video. If you love this video, please don't forget to like, subscribe, share, comment on this video. Thank you.